Hi
right.
everyone, welcome to a crash course in SSH. I'm Chloe. I'm going to be moderating the session, so I'll be in the chat if anybody needs anything. But I cannot wait to pass you over to the fabulous Annette. So Annette is a software engineer with a decade of experience, primarily building web services. She has spent most of her career so far at early stage startups and is currently a staff software engineer at Growth Therapy. So I cannot wait to hear your session, Annette. Honestly, incredible experience so far. I think everyone in here is very excited. So I will hand over to you and let you take the floor.
Awesome. Thank you so much. Thanks for that welcome. All right, so you can see the slides. Yeah, so this is a crash course in SSH. And our goals for today are kind of twofold depending on where you're coming into this talk with. So if you've never used SSH before, the goal is for you to come out of it with some familiarity. So when you see it, you kind of have an understanding of how it works and how you can utilize this tool. If you have used SSH before or you routinely use SSH, I hope that you learn how to use the SSH config file if you're not already using one to make your interactions with SSH much, much easier. So to achieve those goals, we're going to walk through kind of an agenda on 3 parts. The first is just an overview of what SSH is, the protocol. We'll do a tiny bit of cryptography because I'm assuming that we have a really wide background here. And I want to make sure everybody can get something out of this. I am going to assume kind of that you have some base level technical knowledge, right? You're not going to be freaked out if you see a command line or, you're kind of familiar with terms like IP. You don't need to deeply understand those things. Just those are kind of the level of technical background that I'm going to just assume. And then the bulk of this talk is going to be some practical examples of what SSH can do. And these are really pulled from my career as a software engineer. These are all things that I have done routinely. And I also trying to sprinkle in some like lessons learned, troubleshooting tips that helped me over the years. So you just heard my bio. So that is really a good intro. I'm Annette Mechelke. I'm a staff software engineer at Growth Therapy. I like to work at small startups because I like being exposed to everything. That being said, I'm not an infrastructure or networking expert, right? So I'm not an SSH expert. I am a excited consumer of SSH, and that's what I wanted to share with you all. So that's what the goal is, and that's the background here. So let's kick it off with the basics, right? What is the SSH protocol? So I'm going to walk you through like the Wikipedia definition here, right? So SSH stands for Secure Shell Protocol, and it's a cryptographic network protocol. So, right, a protocol means it's just a definition, right? It's not necessarily a specific piece of software. It's just saying, hey, here's a way that we can communicate. Here's like our language. Network, just right, it's over the network, it's over the internet or whatever other type of network you're using. And cryptographic, right? Cryptography is just like the study of like ways to communicate while keeping the content secret from like potential attackers. So SSH is a definition of a way to communicate in a secure fashion, right? And so other network protocols you might be aware of are HTTP, right? That's a network protocol where different browsers implement the protocol. There are you can have multiple implementations of SSH. There is sort of a default open source one called OpenSSH that is what I use and what most people use. So that's what it is. I'm sorry, it's animation there. It's for operating network services securely over an unsecured network, right? So an unsecured network, that's the internet. That's every network these days, unless you're working in a very special space where, you have a significant security team, trying to help you take care of those things. And then operating network services, what does that mean? That just means executing programs, right? It means letting you do things on computers that you don't have access to. So that's like everything that software engineers do today, right? You're almost always never physically at the computer that you want to be working on. And so that's part of why SSH is so important. So how did it become so ubiquitous? So it's generally used a lot throughout the industry, like I was just alluding to. It became ubiquitous. It was created in 1995, right at the sort of start of the internet era, when there was this need for, historically, all the tools hadn't really had security in mind because it was these academic settings where you were all in a lab together. So in 1997, the SSH protocol was defined, and it sort of became the de facto standard for secure communications across network computers at the rise of the internet era. So that's kind of how it solidified its position there. One of the other contributing factors is like there's a really good open source implementation that's been around pretty much since the beginning, and it's widely distributed. It's called OpenSSH. It's been available for Linux and Mac OS for a long time. It in the scheme of things recently is now available on Windows. I think it comes now by default on new Windows operating systems. So it's even growing. And so why is it, so there's this tool that was built, doesn't mean it's good, right? Some of the real things that were done well was it's a flexible architecture that's highly extensible, right? So it's been able to evolve as our tooling and network usage has evolved. And it supports many use cases. So the most common one we'll talk about is like logging into a machine and running some commands. We'll also talk about port forwarding, which is really useful when you need it. You can do it to transfer files. You can use it to run like UI and forward the UI to a separate machine. So it's just a lot of different use cases that come up. All right. So as a protocol, you could go look up like the official RFC and read all the specs. We're not going to do that today. That's not like the goal. But I do think it's helpful to get an understanding of what the protocol roughly is. I think it'll help with the rest of your usage. So the protocol is a client-server architecture, right? So if you're not familiar with that, it's basically saying there's two parties in every transaction. There is the client, that's the person or the computer initiating the connection, and then there's the server, that's like the machine you're trying to get access to. And in your case, right, unless you are a network person or you're a system admin or an ops person, you are almost always just the client, right? You are the one saying, hey, I need to access this resource that's being provided for me. So how does it work? We try to initiate that connection. It is broken up into 3 sub-protocols that each have their own definition. There's a transport protocol, that's the first part. And that's where the client says, hey, I want to connect. And the server says, here's my info, right? So you can make sure you're talking to who you think you're talking to. And then there's this negotiate secure connection part, which is a big chunk of it, but I just kind of want to gloss over that. But this is where that extensibility comes in, right? Like maybe my client is very flexible. I have a lot of different cryptography algorithms I support, but the server is very restrictive and only accepts some. This is where they kind of find a language that they can agree on, find a cryptographic protocol that they can agree on. And once that's done, you'll get your connection between the two machines. The default is going to be TCP, so just sort of how most network traffic for most software engineers goes. And the default port is always going to be port 22. It's the sort of officially assigned port for SSH connections. But going back to that extensibility, it actually can support other types of connections. Just sort of a fun trivia. You definitely almost always use TCP/IP. So you have this connection, right? Your computers have a way to communicate. You still need to authenticate, right? You need to be able to log into this computer, and that's called the user authentication layer. And so this is kind of what you would imagine. You say, here are my credentials, the server checks them, and then you're good to go or you're not. Just like at the transport protocol level, there is a little bit of negotiation, right? Like maybe the server accepts certain kinds of authentication and the client accepts others. The 2 biggest types are either password-based, so just like username and password, or public key, which we'll get into later. And most of this talk is going to focus on public key based authentication because that's sort of the most common in my experience. So some way or other, you'll get your authenticated section. That'll close out the user authentication protocol. And then you get into the connection protocol. And this is really, I really just want to gloss over this because the other two will come up a lot if you're troubleshooting. The connection protocol is just what says, okay, we have this authenticated connection. You can do multiple things, right? You could have a terminal session. You could forward some traffic. You only have one connection. The connection protocol handles what's called multiplexing. So like combining those two streams of data into one connection so that you can do multiple things. But most of that time that just works. So we're not going to worry too much about it. So that's it. That's all I really want you to know about the protocol itself. The little bit I want you to know about cryptography is getting into that public key part that I alluded to. So before we get to the public key part, what came before it? So cryptography, as I mentioned before, is the study of secure communications. We kind of different methods are called like different cryptographic algorithms. And for most of history, right, this was all cryptographic algorithms were symmetric. What that meant was if I wanted to send you a message, we needed to connect somewhere ahead of time and exchange some information, some secret information. So the classic simplistic example of cryptography is what's called the Caesar cipher, right? That's where you just shift every letter by another letter or by a certain number. So like I have my sentence and I would take A, say we agree the number is 3. I take A and map it to D. I take B and map it to E, and I'd apply that transform across all the letters, and then I'd send you this encrypted message. In that case, right, you need to know what number I used in order to decrypt that message. But once you have that, it's a simple operation of just subtracting the agreed upon number. So this works. I mean, Caesar cipher is pretty easy to break because there's like only 26 letters, so you can kind of shuffle it around, but you can get really sophisticated with these. But at the end of the day, there is this issue of you need to exchange the secret information in a trusted fashion before you can securely communicate, right? And this is just a two-party example. If you want to publish something over the internet or have multiple users that can log in, right, you have to manage all these different things ahead of time. So, right, there's definitely a downside to this. So what in the 1970s, there was a breakthrough called asymmetric cryptography. It was symmetric, right, because it's the same key for both people, both directions. In an asymmetric cryptography algorithm, it kind of removes that constraint. And instead of having a single key, you have a key pair, a public key and a private key. And they're not inherently different, like you just deem one of them the public key and one of them the private key. But they're two related, you can think of them as numbers like that are generated based on some like one-way mathematical functions. And they have some special properties that's out of the scope of this little 5-minute introduction. But at the end of the day, you have your two keys. You can publish your public key out to the world. Like you can send it to me and not worry about it being like inspected. You don't care because the property of these keys is that if you encrypt a message with the public key, no one can decrypt it unless they have the private key. So I can take your public key, encrypt my message, and I could publish my message out on the internet for everybody to see, which is effectively what happens anytime you go on the internet, or you should assume. And only you with your private key can actually decrypt that message. And so that's why this is so powerful, because we don't have to have any pre-arrangement. I mean, you have to send me your public key, but we don't have any significant security concerns around that, right? So that's asymmetric, a 2-minute introduction to asymmetric cryptography. The things to take away from this are you have two parts of a key pair, a public key and a private key. And the other part is there are different algorithms. And so that's these different mathematical functions can generate different keys in different ways. And they have different properties that you don't necessarily need to know. You just need to know there exists different ways of doing it. Okay, that's the theoretical bit. So if you don't like the theoretical bit, get ready for the practical bit. You'll hopefully enjoy it. So we're going to walk through a couple of different use cases that have come up for me that I think come up pretty commonly for most folks that work in any sort of like cloud computing adjacent area. The first use case I think is pretty common. I think pretty much anyone that uses Git has gone through this. Git is not SSH, right? It's its own thing, but it has different ways that you can communicate to other Git servers, right? There's HTTP. You can do it that way. You can do it over SSH. And in my experience, SSH is probably the most common way to do this. And I think this is a good example because you can just make sure you get your key set up and everything like that. So you need to get yourself a public-private key pair. That's if you want to initiate a secure connection using this method, that's what you need. Luckily, OpenSSH comes with a tool, right? OpenSSH is actually a suite of tools. It's not just one thing. You almost certainly have it already on your machine if you have sort of a standard anything Linux, Mac, Windows. So you just need to get to your terminal and run SSH keygen. They did a reasonable job naming this, right? It's SSH, and you're going to generate a key. And that's all you, if you get those characters in, you're kind of smooth sailing. It'll walk you through the rest. So it'll say you're generating a public-private RSA key pair. So this is, RSA is one of those algorithms. So there are probably half a dozen very widely supported algorithms. The two that are really popular and that you will probably interact with is RSA. And the other one is ED25519, which I have it written down, but here it doesn't really matter the exact numbers. And RSA is kind of the older one, so it's more widely supported. ED25519 is a little bit more secure, sort of for the same size of key. So the default, at least on my implementation, is RSA. If you don't want to use that, if you have some requirements from something else, you can use the -t argument to just specify a particular algorithm, but you'll know if you need to do that. The next line there says it will enter the file, it's going to save it to user/net, that's my home directory, .ssh/id RSA. So there is .ssh is a directory that either exists or gets created where all of your sort of files related to the SSH protocol are going to live. It's just a default. You can change it. Don't change it unless you know what you're doing. And then the key name is just going to be ID underscore the algorithm name. And then it's going to ask you for your passphrase. So why do you want a passphrase, right? Like this key is secure, right? That's the whole point. Well, the key is like the key, right? Like it's how you're going to decrypt your information. Adding a passphrase is an additional level of security, right? Because if you get this, you have a backup somewhere and your backup is compromised. If someone has this file and you don't have a passphrase, they can decrypt all of your messages. If you add a passphrase, they need both the file and the passphrase. So you want to add one. The only reason not to ever is that you will get prompted to enter your passphrase. And if you're doing sort of a programmatic kind of scripting, you may not want to have to deal with that. But we'll talk about kind of how to ease that passphrase burden in the next slide. So you'll enter your passphrase, and then this last little bit is just saying, hey, I generated your key. ID RSA is the private one. The public one is ID RSA.pub. And then it has two different ways to identify the key. The first one, it's just a SHA-256 hash. If you don't know what that is, don't worry about it. It's just a compressed summary. And then you see Annette at Annette there, blah, blah, blah. So that's my username at my host on my computer. And so that's just going to, if you have all these strings floating around, like you're managing multiple keys, you can imagine you're going to be glossing over like which key is which. So it just adds a little helpful human readable text of like an identifier for this key. If you're going to be sharing your key out, you can consider using the -c command and put in like your email address or whatever other identifier you want to choose an intentional message there as opposed to the default. And then you'll see that there's this random art image, which I had to go look up what this was. It's actually really interesting for exactly this problem of you kind of gloss over these keys and you're never going to memorize them. This is an attempt to kind of make a more human interpretable form. So if you have it configured to show you these random art images, when you connect, you can kind of maybe remember, oh, hey, this computer I connected to used to look like this wonky penguin on the right side, and now it looks like a pyramid on the left side or whatever. So it's a little bit more easily digestible to the human eye. But so you have your keys, yay. And so we know where they went. They went to .ssh / your file. And I think there's a little bit of like, what are these, right? They're just text files. You can open them, you can look at them, don't want to edit them because you'll mess it up, but you can definitely inspect it. And it's really just 3 parts. It's, SSH dash the algorithm, and then it's the actual random like data that generates the key. And then it's that comment that we talked about. So it's not scary. I mean, it's kind of scary. It's like, oh, it's all that text, but that's all it is. The next one here is the private key. So, right, disclaimer, I've already deleted these keys. These are not my real keys. Never actually publish your private key anywhere, but they look like just a begin header, an ending footer, and then a lot of random characters. If you're like me, you might wonder, so it's hard to see on this screen, but the private key is actually much bigger than the public key. And the reason that is because the private key actually encodes a lot of additional metadata to just speed up the decryption process. So the actual like key part is actually a small subset of this. This is also just some additional metadata that makes it a little bit bigger. So you have your key files, you're good to go. Coming back to the Git example, right? This is going to depend on your hosting provider, but you're inevitably going to log in, find some place to upload your public key, and then you'll be good to go. And so this is what it would look like the first time you connected. So this is me cloning my github.io repo. You can see that first line, cloning, that's just sort of standard Git stuff. And then we get into the SSH stuff. So you see the authenticity of host github.com with the IP address can't be established. The key fingerprint is SHA, blah. So this is just saying, hey, you're trying to connect to GitHub. It's telling me this is its identifier, but I don't know if that's true, right? Because you have never connected to it. So if you are very security minded, you can actually search for GitHub's key fingerprints. They have a page on their website. They publish it. You can look at them and say like, yep, those are the same. I am highly confident that this is github.com. I'm not gonna lie, I just hit yes, right? But where this is especially important is if it changes, right? Like if you have been connecting to GitHub for years and then all of a sudden it says this is a new one, that's where I would say, oh, that's weird. I should check, like, did something change? So it says, I said yes. It says, okay, I'm permanently adding github.com with this key to the list of known hosts, which we'll get to in a minute. And then I get asked for my passphrase for that key. And this is actually the ED2551 because I think I saw, yeah, GitHub does recommend ED25192, anyway, numbers. And so I have to enter that. And then we get back into just the pure Git part of it. So it works. It's relatively easy, but we can make it easier by creating a config file. So a config file is, again, just a plain text file that lives in the .ssh directory. So you'll need to create it if you don't already have it. It's composed of these host stanzas. So you basically will say, this host identified by this pattern, and then you just give a list of options that you want to apply. You can use wildcard matching and all that jazz. So this is saying for every connection, host star, I want to do 3 things. I want to add keys to the agent. So just like SSH keygen, there's another tool that comes along with the Open SSH suite called the SSH agent. And this is just a background process that runs that manages all of the identities on your computer, right? So if you had multiple files, key files for some reason, it would be able to keep track of them. And you may need to start the process if it's not already running. But once you have it running, you can just leave it, set it and forget it. And what this config says is whenever I enter a key and a passphrase, just remember that and don't make me do it again, which is what we want. So we don't have to enter our password every time we push or pull or do anything with Git. This next one is use keychain. So this is Mac specific. It's just saying use the Mac OS keychain. I only am putting it here honestly, so it's an excuse to say you can put comments in this file, right? So if you have a Windows, you don't want to have that there, it'll get confused. But you can use hash for comments. And then again, so identity file, this is just saying, hey, always use my ID RSA key. Most of the time, you probably only have one key, but if you're sort of an advanced user and you have multiple keys for different reasons, you can set which identity file you want for different connections. So that's it. You can now push and pull from Git with no prompts, nothing going on. And let's pause and look at that .ssh directory. You can see in it, there's going to be 4 files now. The config file we just created, the public and private key we created, and then this known hosts file. So known host, if you remember that phrase from a couple of slides ago, that was where we were warned we're going to add GitHub to our list of known hosts. And again, that's just a text file that's saved on your computer. Once I connected to GitHub and I accepted those keys, what happened was SSH wrote 3 entries into this file. They all say github.com, the algorithm, and then the key, the public key. And you got all 3 because once you agreed to it, like it was publishing 3 available options. And so it said, well, if you're trusting one of them, I'm going to trust all of them, and I'm going to write it there. So this is what prevents you from getting that prompt about, do you know this server repeatedly. And as you use SSH throughout your days, your known host file will just grow and grow for every connection you make. Okay, so that's it. That's like making sure your SSH is set up and configured and works. Let's say we actually just want to use SSH, right? The SSH command, right? The application is, or the use cases, say you want to run an application in the cloud, right? You want to set up an instance on EC2 or Google Cloud or Azure or whatever. You might SSH to that instance. So the command is just SSH username at host, right? So this can be IP, this can be a DNS entry, kind of anything you can resolve. And this is what people mean when they say I want to SH, to something. So your hosting provider would give you an insight into like what is the username and what is the DNS or IP you should connect to. One call out is a little bit different for like containers and things like that. So this is sort of more of a straight up like virtual machine kind of thing. You could certainly set up SSH on containers. It's not really a use case that I have seen a lot of. Okay, so all of my examples are on EC2. My background is primarily AWS, but it doesn't matter. You'll just see the EC2 logo in a couple places. So when you set up you instantiate your server, you'll probably give them your public key. Ideally, you'll be able to give them your public key, and they'll automatically install that into the server to accept your connection. Maybe not. Maybe they'll just say use this username and password. But it should be pretty straightforward one way or the other. So this is what it looks like, right? So I spun up an EC2 instance. The default user for EC2 is EC2-user, and that's just the IP address that I got out of the EC2 console. So I just typed SSH EC2 user. You can see I got that same like authenticity of host message. I said yes. Again, I could probably go figure out somewhere in the console to confirm that, but I'm expecting this to be a new machine, so I just said yes. And it's great, it works. But sometimes it doesn't, right? Like it's never quite that smooth sailing. So what do you do, right, when it doesn't work? SSH has a -v argument, so that is verbose logging. And so you can just add that to your command, and it can help you troubleshoot. So coming back to that protocol, there's really 2 places where this can fail, right? There's the transport layer, which is where it's saying you can't even establish a connection. So like this case, I added a firewall rule to prevent connections to port 22, right? So that won't let SSH traffic through. And so what happens is it just hangs, like, because it can't get a connection. It will time out eventually, but it'll just sit there. So if you're ever SSHing somewhere and it's just not doing anything, you probably are having some sort of networking issue getting access to that. The other reasons this might fail, like maybe the IP address isn't right, like maybe you're using a private IP address, but you're not on the private network. The one thing to call it here is if you use DNS, it'll also show you the IP address. So maybe your DNS isn't resolving to the right IP address. So all these sort of networking level things that can go wrong. The other way that transport layer can go wrong is if you can't agree on a protocol, like maybe the server is really old and your server and your client is very restrictive, you might not be able to find a sort of new enough algorithm that you can agree on. So that's how the transport layer might fail. The other layer, right, is user authentication, right? This is going to fail because either your username or your key is wrong. So you'll see in the logs here that it'll say connection established. That means the transport layer worked. You'll see it's authenticating. In this case, I left off the user. So it's going to try to use my local machine's user. And that's not going to work because there's no Annette user on my EC2 instance. But you'll see it'll show you which keys it's offering. It'll see which authentication methods are available, and then it'll sort of culminate in this permission denied. And so, right, the things to troubleshoot here, make sure the username is correct, make sure the path to your key is correct, all that kind of stuff. And hopefully that'll get you through. What if the key is correct and it's still not working, right? You kind of need someone else to help you at this stage, but your authorized keys is a file on the server. It's still in that .ssh directory, and it's just a list of public keys that are allowed to connect, right? So you might need somebody to get on that machine and add your authorized key for you. So that is, it might have, point here is like there's different algorithms and that's fine. There's different people, just a list of keys. Okay, so you made it to your server. Yay, everything works. Let's add it to the config file. So if you have a server you're going to connect to a lot, you can add sort of a named host configuration. So I called mine my server. I put in the IP address for the host name. I hard-coded in the username so I don't have to remember. And then I can just do SSH my server, right? And depending on your terminal, mine like auto-completes at this point. So it's super nice, super convenient. Makes my life easy. Say you want to put a file in your server, right? You want to run your app. Lucky for us, SCP and SFTP, two of the most common secure file transfer programs, work with SSH config. So you can reference your my server in SCP or in SFTP, and it makes your life easier there. Okay, that's that use case. You connect, you put some files on there, everything is great. You become super popular and you now are a startup and you have a little bit more infrastructure, right? Maybe you have some app servers, some databases, things like that. You might set up what's called a VPC. And so it's not really the context of this talk to talk about like what is a VPC and how to do that. But what you may run into in sort of more professional settings is what's called a Bastion host or a jump server. And so the idea is roughly that you know, you're going to have a lot of infrastructure rather than like worrying about managing SSH keys and all of the security associated with public access to all of your infrastructure. You designate one host, the Bastion host. You kind of lock it down very securely, and you force everybody to go through that that host before they can get into anything else. So this is a pretty common paradigm. So let's talk about some ways that SSH supports this. The first case is, so say you have that app server and you want to get on there and like look at some logs or do something, right? So what you need to do sort of philosophically is to go SSH to the Bastion host and then SSH to the app server, sort of 2 steps. You could do that manually, but we don't want to do that, right? We're good, lazy engineers. There's a command for that, or there's an argument to the SSH command called a jump proxy. It's specified with a J. And you basically just string them together. You put in the Bastion host information, you put in the user, the destination host, just back to back. And what it'll do is jump from one to the other, like we talked about, sort of philosophically. So this isn't too bad of a command, right? You have to remember your user, which user's which. You have to maybe remember IP address, but you can use the Bastion host if we set that up in the config. So this is kind of the worst case scenario of what you might do. But let's put it in the config file. In the config file, this option is called ProxyJump. So you would say, I'm going to call this host app server. I'm going to hard code the IP address. This one's Ubuntu instead of EC2 user. And every time I connect to it, I'm going to proxy jump through the Bastion host. So this Bastion host is the same config as for my server. I just renamed it Bastion host for this example. Once you've done that, you can just SSH app server, and it'll hop you right to, it'll go through the Bastion host without you having to worry about it, which is pretty great. But you can kind of go above and beyond, right? In this scenario, pretty much everything is going to be in a private IP address inside of that VPC. So you can put in some wildcard host configuration to say, hey, anything that's on the 10.private network, always go through the Bastion host, because I know that's the only way I'm going to have access to it. So that is a great way to do that. You can do it, it depends on your configuration, how you set up that wildcard, but it's definitely doable. And then I can just do any 10 dot address and it'll go through the Bastion host. All right, last one, which is, say you don't need to get to the host, right? But you need to access like a database server. You need to get access to MySQL. It's running on port 3306. You have to go through your Bastion host, but you can't set up SSH to your database server directly. This is where you want to use what's called local port forwarding. So there's different types of port forwarding, but this is called local, so it's -L. This is another, it makes sense, but it just gets really long kind of command. You choose your local port, which I did 3307 in this example just to distinguish between, but you could do 3306. You could do any port you wanted effectively. And then you say the destination. So in this case, the database, the port. So in this case, the database port. And then you say, okay, I'm going to go through with the Bastion user and the Bastion host. And just kind of populating through here, this is what it might look like. Again, you know where this is going. How does this look in a config file? We can do this two ways. The config will look the same, but you can add this local forward to your SSH connection. So you'll open your terminal, but you'll also have this forwarding tunnel in the background. And I switched to 3306 here, so it's supposed to be 3307 to match with the other picture. But you can see I have the same host, the same IP for both. You can set up multiple configurations. You could say, okay, if I am not going to do local development, I just want to check something out, I can go to the Bastion host, or I can set up the tunnel itself. And then there's two ways to run it from here. You can just run SSH tunnel, and that will open you a terminal and have that forwarding port in the background. So you could run your app against that local port. Or you can add a little bit of some additional flags to the SSH command. F is saying put it in the background. N is saying don't run any commands, and T is saying don't open a terminal. So what this does is this effectively just opens that port forward in the background, shuts it. There's no UI option. It'll just be there behind the scenes. So if you want to kill this, you kind of have to go find the process and kill it, or it'll naturally time out eventually. But kind of depending on your use case, you can do either one of those. So that's it. That was sort of a breakneck run through the ways that you might use SSH in your career as a software engineer. Right, the takeaway is SSH can do a lot of stuff, and you can use a config file to make it easy to do that stuff. So yeah, thanks everybody. Those slides aren't there yet, but they'll be on my website once I get around to publishing them later today. Yeah, questions, I guess.
That was incredible, Annette. I loved that talk. And yes, if anyone has any questions, put them into the chat. I think there was one there from Nadia, is SSH the only internet protocol for accessing network devices?
Yeah, good call. No, it's not. And so I think it is the most common one. Like I don't know how to do that sort of the command running one. I don't know if there's any, but there's definitely other ones for specific use cases. And just to pivot a little bit into something I actually don't know the answer to, but just to share, right? As we're moving towards more like containerization, like the way that you connect is a little bit different. Like I use EC2 a lot, and Amazon has their own SSM tool that's like secure session manager that they want you to use. But what's interesting is they actually have plugins for it to work with SSH, and that's where that kind of extensibility of SSH comes in, is that they're kind of building this hybrid that you can use SSH and their custom tool. Yeah, I can go back and explain the port forwarding. I was trying to not run out of time. So the use case for port forwarding is, say that you are running an application that connects to a database, right? You can maybe run a local version of that database. Maybe it has some data in it. But maybe there's a testing database that has more realistic data that is going to be easier to test your app with. What you can do is set up this port forwarding, and then you can, run your app locally on your computer, not inside of the VPC. But you can then have your app configuration pointed to localhost :3307 in this example, and it will go through the tunnel and it will get to your test database. So that's the use case that I have most seen. It can be not just databases. Maybe there's another server you need, another service you depend on. Maybe there's a cache, but it's basically something where you would want to run an application locally but have a dependency outside. On the topic of tunnels, like if you are making extensive use of tunnels, like there are UI programs that you can use to kind of set up much more complicated scenarios. So obviously this talk is focused on like what you can do with SSH sort of out of the box, but there's definitely tools to help manage that if you're an extensively like doing port forwarding. Yeah.
Awesome. Any other questions from anyone? No, well, that's great. There's so many amazing messages in that chat for you. I think
Thank
it's
you.
safe to
Yeah.
say we all learned a lot from that session. So thank you so
Good.
much, Annette, and I hope everyone
Yeah.
enjoys the rest of the conference.
Yeah, of course. Thank you all for coming. I appreciate it. Yeah, so my socials are all on my website. So it's just annette.mechelke.us. And I have a very simple web page, but it links to all my other stuff. So hopefully that can put that slide back up. Oh, I'm going the wrong direction. There we go. Yeah, love to connect. Cool.
Perfect. That was great. Well, thank you very much. And we'll let everyone get into their next sessions then a few minutes early.
Okay, thanks so much.
Bye.
Bye.